Hello everyone, so this is going to be a reteach on how to do the peaks, gaps, and clusters in the data distributions on our classwork from Thursday. So please pay attention because this is really important to know when we're describing and understanding data distributions. So I wanted to just reiterate what a peak, gap, and cluster is. A peak is where most of the data points are. So if I look at this dot plot or line plot, and I see where most of the x's are, do you see how right here there's 3? So this is the highest amount. And if you compare it to every other column of x's, this is the highest. So we call this the peak. So if I was to label this, I would say the peak is at 2. I would do it based on the number line. So let's say I was looking for gaps. So what gaps are where we don't see any data between two groups of x's. Or groups of x's, I should say. So if you notice here how there's some x's here at 4, and then there's x's here at 7, there's this just empty space. And we call that a gap. And so if I was to describe this gap, I would explain it as an interval. And that would mean I would say that the gap is from 5 to 6. And so that's what a gap is. Now, a cluster is just where you see a whole bunch of x's huddled together for warmth. I like to think of it that way. So a cluster is just where you see all the x's without any gaps or any spaces in between. So if I look right here on this cluster, I have a cluster of all these x's. You see how they're all together. There's no spaces like this. So this is a cluster from 2 to 4. And I would write that 2, little line or a hyphen, and then 4. Now if you look over here, there's another set of amount of x's, which is a cluster. So if you notice from 7 to 8, this is another cluster. So that's how you identify peaks, gaps, and clusters. Now this is the one that a lot of people had trouble with last Thursday. This is our data distributions. There are 3 main things that when I ask you on a question, what is the data distribution or the shape of the dot plot, you need to pick one of these 3 and you have to describe why. So let's start from left to right. So if I look right here, this is called a skewed right distribution. And so it's called skewed right because most of the data starts disappearing or going away to the right. But most of the data is actually on the left. So you have to remember it's the opposite of where the data is located. So if you notice here, most of my data is to the left. So my distribution is skewed right, despite it being on the left. A symmetrical distribution is where it looks like it's symmetrical, where it's even across a line. So if you notice here where the peak is, where I see a peak at 6 because there's the majority of x's. And notice on both sides there's 3 x's, then 2 x's, and then 1 x. So that's what we call symmetrical distribution. It goes symmetrically across both of these. Now, lastly, a skewed left distribution is just the opposite of a skewed right. All of my data is on the right side of the plot. So remember the opposite name. Skewed left means most of the data is to the right. Or another way you can remember it is most of my data starts disappearing to the left. So it's called a skewed left distribution. Now let me show you how we're going to do that on that assignment from Thursday. I want you to go back and fix this. Please go back and fix this and make sure you understand the difference. So let's start on the left-hand side. So the question says, type the name of the data distribution that best matches the line plot dot plot shape. So again, that's either skewed left distribution, symmetrical distribution, or right skewed distribution. So I want you to fix these. I'm going to show you 2 of them, okay? So if you look right here, I have the age of presidents and inauguration. So I'm going to just draw a shape that closely follows the x's or the dots to help me in verifying that. So I'm just going to draw the curve, and it's going to go across and go right here. So if you notice that the majority of my data is to the left, so it is a skewed right distribution. So it's a skewed right distribution. Skewed right distribution. So you would have to type. I can draw because of my tablet. So that's called what we call skewed right distribution. All the data to the left starts disappearing to the right. So now let's look at this one. So again, I just want to reiterate. Those 3 distributions, those are ideal cases. We're only trying to figure out which one best represents the plot. So now if I look here, I have the length of book titles. If I do again the same thing closely. So this one you can almost argue both 2 different things. I would personally think this is symmetrical because it is symmetrical about the peak at 2. Because there's 3 here, and there's 2 here, and then 1 here. It's not ideally symmetrical, but it's very close. But I could also see, if you wanted to argue, most of the data looks also to the left. So I could also see if you were to say it was skewed right. This is why I asked you to please tell me why. So it could be symmetrical or skewed right. So again, it's your interpretation. It's what you think best represents it. You only have to pick one. You don't have to put both of these. I want you to pick which one you think it is. Now, let's go over to the right-hand side. And that's how you do these 4 over here. You're doing that same thing. You're just saying skewed right distribution, symmetrical, or skewed right. So you just have to decide which of those 3 it is. Now, on this one, this is type the interval or number where you see a gap, cluster, and peak. So let me better explain this. So again, remember what we looked at on the notes. This is a gap right here. We have a gap right here. And then we have a cluster. If I was to do a cluster, this is my cluster because all of my data points are together, and then this is a gap because there is no data between here. So your clusters and your gaps, they have to be written in interval notation. Now let me show you what I mean by that. So I did red for my cluster. My cluster starts at 4 and goes to 7. So I would write 4 to 7, and then I know it's percent, so I put percent. My gap is from 1 to 3. So 1 to 3. I'm going to do, I need blue, 1, 2, 3%. And now I look for my peak. That is just where the most X's or dots are. If I look on my peak, right here, this is where the highest column of dots are, and that's at 6. So I'm going to represent that with green. So my peak is at 6%. And that's how you do these ones. Let me do one more. So if I look at this one, I see that there is another cluster. This one has a cluster across the entire thing. So from 2 to 6 is my, oh, sorry, that's not right. From my cluster, 2 to 6 words. So 2 to 6 words is where my cluster is. Do I see a gap? No, because there's no gap between any dots or X's. So there's no gap. So I would just say none. So I'm going to put, again, the same color. Oops, I did the wrong color again. Sorry, guys. I want to make sure this stays. So this is none. And then my cluster is 2 to 6 words. And then my peak. My peak is where most of my data is. Most of my data is right here. If you see how tall it is, it's the tallest one. So 2 is where my peak is. So I'm going to keep it 2. So that's how you're going to do the homework and fix it today. So please do that and then move on to the new problems that we're going to be doing today. So best of luck to you and ask questions during class. Thank you. And again, remember, that's what you're doing on the right-hand side.